I will give you formulas on the quiz. You will have to be able to apply them to the situation, all right? If we have an area problem, guys, an area of a sector, all that is like the piece of the pizza or the pie, right? This is the area. If I said, what's the area of the shaded region, something like that. The area formula is r squared times theta. Theta is your central angle, r is your radius, okay? So if you need to write down radius equals r, that's good. Central angle, guys, has to be in what? Has to be in what kind of a measurement before you can use any formulas? Got to be in radians. If you don't make that conversion, if you don't convert from degrees to radians, if they give you degrees, then you're going to have problems. You guys are going to get it right. So let's make sure that we pay attention to that, please. So if I get this example, I like to write area as, hold on, area equals r squared times theta divided by 2. It's the same as times 1/2. I just like the way that looks better. So if I look at this problem, it says find the area of a sector with a central angle of 60 and a radius of 3. So they're telling me that r equals 3, right? You guys agree with me? 3 meters. And they told me that my theta is 60 degrees. Can I just plug 60 degrees into this formula and get my answer correct? No. What do I have to do first? I have to convert. This is 60 over 1. So where does 180 go, on the bottom or the top? On the bottom, because I want the degrees to cancel out. Good. Pi goes on top. So the 0 and the degree sign will cancel out because 10 goes into both of those. And then 6 goes into 6 once, and 6 goes into 18 3 times. So your theta that you're going to use in your problem is pi over 3. Now you can plug it into the formula. All right, so when I plug this into my formula, exactly like I see it, I'm going to say 3 squared times pi over 3. And then I'm going to say divided by 2. If you want to put 1/2 in the front, that's fine. Now when we simplify, 3 squared is how much? 9 times pi over 3 divided by 2. Can I simplify a little more on top? With 3 and 9? 3 goes into 3 how many times? Once. 3 goes into 9 how many times? 3 times. Hang on one second, guys. Okay, so I'm left with, this is 3 pi over 2. Now, on WebAssign, that's how they want your answer. Okay, this would be 3 pi over 2 meters squared. You're leaving that in terms of pi. If you are asked this question and it says round your answer to the nearest decimal, you would in your calculator say 3 times pi divided by 2, and you'd get 4.712 meters squared. Depending on what the question asks. These two things are the same, but in WebAssign, I'm pretty sure they don't say anything about rounding. That means leave it in terms of pi. So you would leave it like this, 3 pi over 2. Questions? What's really important to remember about the central angle? Got to be in radians. Yes, ma'am. Because it's area. Good question. All right. We're going to talk about linear speed here. The next 2 slides, I'm just going to talk, and then we're going to do 2 more examples, and then we're done. Linear speed. Linear speed is how fast something moves. It's the rate at which the distance traveled is changing. So linear speed is the distance traveled divided by the time elapsed, okay? Everybody look up at the clock. Do you guys see the red seconds hand? Okay, if we're going to do some problems today that have to do with the hour hand and the second hand. Notice the red seconds hand. Does it speed up and slow down at different intervals? Or does it go the same speed all the way around, right? Okay, how many seconds elapse if it goes from 12 o'clock all the way around to 12 o'clock again? 60, okay, let's just make sure we know that. If I cut my clock into quarters, into fourths, how many seconds are in the first quarter? 15. How many's in a half? 30. How many's in 3 quarters? 45. Okay, good. So we're going to find the linear speed. All right, linear speed is what we're going to focus on right now. We'll talk about angular speed later. But linear speed is S divided by T. Does anybody remember what that S was? S was arc length. All right, you're going to have some questions tonight on your homework about arc length. The formula for arc length is radius times theta. So all you're doing with linear speed is you're finding the arc length and you're dividing it by time. So you can look at linear speed, we can call it LS if you want to, is radius times theta divided by the time. Okay, does everybody see that? So the kinds of questions that we're going to deal with I'm going to deal with just a clock. So I want us to look at this next. I wrote this by hand. If I read this question, it says a clock has a second hand that measures 5.64 centimeters. What's the linear speed of the second hand as it makes a full revolution around the clock? A half turn, 3/4 turn, 1/4 turn. Now, we just talked about this. Linear speed equals R times theta divided by time. When I look at this question, what did they already give me in number form? Which part? R, theta, or time? What did they already give me? They already gave me R. How do I know that? The second hand, look, it goes from the middle to the outside, right? So they already told me in this problem that R equals how much? 5.64 centimeters. Now they told me my central angle and they told me the time just by saying this. A full revolution, half turn, 3/4 turn, 1/4 turn. They already told me that. And that's why I drew the pictures up top. All right. Our central angle has to be in what? Radians or degrees? Radians. So if I'm looking here, we'll start over here at the end. If I'm looking at this, the blue circle to the far end. If I start right here and I go all the way around my clock one time, how many radians is that? One full circle is how many radians? 360 degrees, or the same as 2 pi. Okay, so my central angle, if I'm doing a full turn, is 2 pi. What is the second? How many seconds elapse if I go one whole time around the clock? 60 seconds. So then I'm going to look at the next one. How much of my circle is colored in here? 3/4. Okay, what's the time if we're talking about 3/4 of a minute? 45 seconds, good. Now let's think about this. Right here, over here we're starting, it's 0 or 2 pi. If I go up to the top, it's pi over 2. If I go halfway around, it's pi. If I go down to the bottom, it's what?
2 pi over 2.
Flip it.
3 pi
3 pi over
2.
2, yep. 3 pi over 2. So if they tell you that the clock, the second hand, makes a 3/4 turn, you use 3 pi over 2 for the central angle and 45 seconds for the time. What about the next one? 30 seconds, good. So your time here is 30 seconds. What's your central angle? What is it? 2 pi is one whole circle. So how much is a half? Just 1 pi, good. And then if I make a quarter turn, what's my theta here for a quarter turn? What's 90 the same as? Think about 180. If I cut 180 in half, it gives me 90, right? So if I cut pi in half, what does that give me?
Oh, pi over 2.
Good, pi over 2. Now, if we're talking about time, how many seconds elapse in a quarter turn on a clock? 15. So when you have a word problem and they tell you how much of a rotation the second hand makes, they're telling you the central angle and they're telling you the time. So we're going to work all 4 of these problems, and I want you guys to see what happens as we do this. All right, first problem we're going to do is a full rotation. So for a full rotation, I'm going to say my radius is 5.64. What's my theta for a full rotation? 2 pi. And we're going to divide that by 60 seconds. You guys agree with me? Okay? So let's do this in our calculator. Hit 5.64. 5.64. Parenthesis 2 pi. I'd close your parenthesis and enter. And then divide that by 60. And what do you guys get? .59 centimeters per second, okay? Agreed. Now we're gonna work this problem out, and we're gonna work it out as a half. Okay, a half turn, right? That's the next thing. So my radius stays the same. It's 5.65. For a half turn, what is the central angle that I use? What's the central angle measurement? Pi, good. And then what do I divide by? How much time goes by in half of a turn? 30 seconds. Okay, so let's do that in our calculator. 5.65 times pi divided by 30. Oh, my bad. This should be 4. Thanks. Thank you. I don't know why. 5.64 pi divided by 30. What do you get? 0.59 centimeters per second. Okay. So let's do a 3/4 turn, see what happens there. It's a 3/4 turn. So again, my radius is 5.64. What is my central angle? What is my theta for a 3/4 turn? 3 pi over 2. Good. And then what happens? How many seconds go by in a 3/4 turn? 45. So let's do that in our calculator. 5.64 times, I'm going to say 3 pi divided by 2. And then divide that by 45. What'd you guys get? I got 0.59 centimeters per second again. Okay. Let's go. Let's do the last one, a 1/4 turn. So for a 1/4 turn around our clock, again, my radius stays the same, 5.64. What is the central angle? What's the theta I use for a 1/4 turn, guys? Pi over 2, great. And how much time elapses in a 1/4 turn? 15 seconds. So let's do that in our calculator. 5.64 times pi divided by 2 divided by 15. What'd you guys get? Why do we keep getting the same number? Every single time we did this, we got the same answer. Why is that? Okay, we changed, we kept in proportion what goes with what. However much the turn was, you have to use that central angle and that time amount. But the linear speed stays the same. What did we talk about at the beginning of this class when I told you guys, look at the red second hand? It doesn't speed up and slow down over the different intervals, right? It stays constant. So if you have a question like this, and if you put in your numbers correctly, like if it says a 1/4 turn, you use pi over 2 and 15. If it says a full turn or full revelation, you use 2 pi and 60. Your linear speed will be the same at whatever central angle and time you use because it doesn't speed up or slow down. Does that make sense? Okay, good. Okay, good. So it's really important, guys, that you know this my beautiful diagram that I drew. It's important that you know those increments. And remember, our central angle, every time we do this, has to be in what? Gotta be in radians. Okay.